Now see here amplitude modulation. Here we will be dealing here with the mathematical aspect of the amplitude modulation. Now see, suppose you have got the carrier wave whose mathematical equation can be given, that is mean displacement at any time t for the carrier wave is AC sin omega ct, where omega c can be written 2 pi nu c. Omega c is the angular frequency of the carrier wave, nu c is the frequency of the carrier wave, and now we can write modulating signal mt is equal to am sin omega mt, where omega m is equal to can be written 2 pi nu m. Am is the amplitude of the modulating signal, that means the signal which has to be modulated, and AC is the amplitude of the carrier wave. When you are modulating them, we can get the equation for the modulating signal, that is CMT is equal to AC plus this one MT here AM sin omega m t into sin omega ct. Now see here we can take common here AC. So if we take common AC, so we will be getting 1 plus AM upon AC sin omega mt into sin omega ct. Now see, in this case AM upon AC we can replace here, mu is equal to AM upon AC. AM is the amplitude of the modulating signal, AC is the amplitude of the carrier wave, and this mu is known as over here, that is called modulation index. See here modulation index, that the value of the mu we must keep less than or equal to 1 to avoid distortion in the signals. So this is about here. Now we can simplify this further and we can write CMT is equal to AC into 1 plus mu sin omega mt, that is sin omega ct. Now we can solve it by using here the trigonometric relations. So we will be getting AC here sin omega ct plus AC mu sin omega mt and sin omega ct. We can use equation for the sin A, sin B, that can be written here AC sin omega ct plus, that is AC mu by 2, that we can write here cos omega c minus omega m into t minus cos omega c plus omega m into t. This equation we can get. So see here we have got three frequencies, omega c minus omega m and omega c plus omega m. So we can write here omega c, that is the frequency of the carrier wave, omega c minus omega m is the frequency of the lower side band. So we can write LSB, lower side band, and omega c plus omega m can be written here upper side band, that is USB. So these frequency range we can get. We can say this frequency spectrum with the help of the graph also. So we can draw the graph for this, and the equation which I got last one, that is the equation for the amplitude modulated wave. So the graph we can see here, we can take a frequency this side, and here we can take amplitude, and it is here omega c is here, that's amplitude is suppose A, we can take AC, and then omega c minus omega m, omega c minus omega m, omega c plus omega m, amplitude for this AC mu divided by 2. So this is the frequency spectrum for the modulated wave, where the lower side band and upper side band of the frequency has been shown.